In Concept B, we're going to be focusing on covering properties and changes of matter. So starting off with properties of matter, we're going to focus on physical and chemical properties. Physical properties are constants about a substance. These can be measured without changing the identity and composition of a substance. So we have extensive and intensive. Extensive is a physical property that depends on how much you are dealing with. So measurements like mass, volume, length, weight, these all depend on the size of the sample. Thus, if we change the size of the sample, these properties will change. However, a lot of the properties that we deal with are intensive properties. This does not depend on the amount that you are dealing with. Due to this, the properties can help us identify matter. So extensive properties do not allow us to identify the type of matter. However, intensive properties do. So great examples would be density always remains the same. Melting and freezing point, boiling point, color, texture, solubility, how well something dissolves, odor, appearance, and more. So again, all of these do not depend on how much you are dealing with, unlike our original extensive properties like mass and volume that do. Chemical properties, these include behaviors that substances adhere to or follow when they react with other substances. So these are all about what it can react with. So examples are heat of combustion, reactivity with water, reactivity with acids, flammability, reactivity with oxygen. So these are properties that deal with reacting with something else potentially. Also, we can observe these properties through a chemical change. So let's look at these two examples. Let me just pull up the pen. What statement describes a chemical property of iron? So we want to look at, again, what types of properties here are we dealing with that's going to change the type of matter. So iron can be flattened into sheets. Unfortunately, when we flatten it into sheets, it's still iron. So we have not spoken to changing what iron is. Iron combines with oxygen, so we're talking about it reacting with something. So that's potentially a correct answer. B, iron conducts electricity and heat. This is something about iron. Nothing's going to change about it. And then D, iron can be drawn into a thin wire. This also is going to be a physical property, its ability to change shape. So that means then that our answer is C, chemical property is when it can combine with oxygen to form rust. Number 2, an example of a physical property of an element is the element's ability to, here A, react with an acid. As soon as we see anything about reacting, we want to get rid of it when we're talking about a physical property. Choice C, form a compound with chlorine. We're talking about a reaction here, a chemical change. So this would be a chemical property. B, it's going to react with oxygen. No, because again, react is, we want to say, is chemical. Or form an aqueous solution. Forming an aqueous solution is simply meaning that it's going to dissolve, or its ability to dissolve, which means then that that is a physical property. We're not actually changing what it is, we're just changing the appearance and so forth. So choice 2, letter D. So let's move on to changes of matter. A physical change is a change that does not alter the chemical properties of a substance. Whatever chemical we start with, we're going to finish with. No new substance forms, the same particles are simply arranged differently. So good examples of this would be changes in state, such as boiling, freezing. So we're changing the phase. Changes in appearance, so if we dissolve something. Changes in shape, if we flatten something, draw it into a wire. Or changes in size, such as cutting the sample or grinding a sample. These are all examples of physical change. So this is a particle diagram representing that physical change. We are starting with water and we are ending with water. We're simply rearranging particles. So again, this is where that rearrangement of particles is what we're primarily looking at. Okay, we haven't changed the chemical substance. Alright, but let's look at chemical changes. This is when the composition of a substance does change. So the composition of the material is entirely different after the change. We have a new substance. So good examples and kind of keywords, especially when it comes to burning, combustion, rusting, tarnishing, decomposing. Also, if you simply just see reacting, okay, or forming a compound with, those are all, again, examples of chemical changes. So here you can see that we start with water and we change into oxygen and H2. So while we start with water and we end with H2 and O2, We're changing the chemical substance. We have a new product. Thus, this represents a chemical change. So let's look at these two questions. One, which process represents a chemical change? So we want to think about, again, we're changing the chemical composition. So melting of ice, this is a great example of physical. This is a phase change. Same thing, evaporation of water, we have a phase change. So that's a physical change. We have corrosion of copper, that looks pretty good. And crystallization of sugar, that is also a phase change. That's when we go from a liquid to solid. So that is also not an answer. So that means B, corrosion of copper, which represents a physical change only. So remember, this is what we're starting, whatever we start with, we end with. We're just simply looking at rearrangement. So A, we have two different types of particles, and we can see that we still have those two different separate types of particles. C is not going to be correct because here we have a compound, and then here it's separated out. So we've gone through a change. B, we have separate particles on the left, and here they've combined into a compound, so they've reacted. So this is a chemical change. And then D, we have two different types of compounds, and here they've combined into one. So that's also a chemical change. So A is the only one where we're starting with separate elements and we end with separate elements. There's been no chemical change, no new bonds or compounds. So our choice is A. All right, so we're going to quickly just talk about some separation techniques, and you'll find that all of these are different types of physical separation techniques. And you need to know this because physical separation techniques, remember, are how, when we're dealing with mixtures, chemical separation techniques would be if we had compounds, which you're going to not see any in this case on this next 4 slides. So our first type of separation technique is filtration. Okay, this is a physical separation technique, so for separating mixtures, the mixture throws through the filter, undissolved solid particles remain on the filter paper. So a great example of this is like a type of heterogeneous mixture where we have a solid mixed in with a liquid, such as with sand and water. Evaporation. This is going to be a physical separation technique. We boil the solution to separate dissolved solid from liquid. So this works for homogeneous mixtures such as dissolved salt and water. Distillation. This is a physical separation technique. Okay, the key word you always want to look for is boiling. When you talk about separating substances by their boiling points, you're talking about distillation. So this works great technique for if you're separating two liquids out from each other, a type of homogeneous mixture. Chromatography is also a physical separation technique. You guys did this with leaves in biology. You separated out the pigments. So it's often a common piece is such as pigments. And I guess that would actually be an example over here that we could include. So we're separating particles based on size and especially solubility, so how well the different parts of the mixture dissolve into the liquid that we're using. So homogeneous mixtures such as a mixture of pigments would be a great way to apply chromatography. All right, so that is everything. You are all set.